Hello, this is Dr. Keith Miller again, and what we're going to do in today's hands-on video is look at making and interpreting geologic maps and cross-sections. So in the previous video, we looked at the characteristics of different types of folds and different types of faults and the terminology that's used to describe them. So what we're going to do today is see how those structures, those folds and faults, are expressed in geologic maps and cross-sections. In understanding and interpreting geologic maps, one of the most important things to do is to understand how to visualize things in 3 dimensions. And this doesn't necessarily come naturally to many people. And one way to do this, to train yourself to see in 3 dimensions, is the use of block diagrams. So that's what I'm going to be focusing on, is looking at block diagrams and seeing how map views are reflected in vertical cross sections. So without any further discussion, let's get going. These involve just tilted beds. So let's first look at a block diagram. So the surface, the upper surface, is equivalent to the map views. This is like an aerial view looking down from the top. Then we have 2 cross-sectional views, that is vertical cuts that are at right angles to each other. And that makes up this cube. So that's the way all block diagrams are designed. The top view would be map view. And then we have 2 cross sections at right angles. So let's first look at this one. Okay, what we have are a series of beds. These lines represent the contacts between geologic units. And there's 2 pieces of information here. One is the numbering of beds. So throughout this exercise, these exercises, beds will be numbered in the order from oldest to youngest. That is, from those that would be at the bottom of a stack to those at the top. So here's 3, 4, 5, 6. Okay, so this bed, this unit, would be at the bottom of the stack. So that's our first piece of information. The other is these strike and dip symbols. We've talked about strike and dip symbols in the previous video. So these strikes on these beds are parallel to the contacts. So they're striking east and west, and they're dipping toward us. They're dipping to the south, okay? And they're dipping at 30 degrees, which might be a little hard to see here. So they're striking east and west and dipping at 30 degrees to the south. So what we can do then is draw this side of the block diagram showing that the beds are dipping about 30 degrees. So we'll just kind of approximate that. So here are these 3 beds that are marked at the surface. And we'll just add a couple more here to give a little more impression. Okay, so there is that side of the block diagram. And because these beds are striking east-west, we can simply draw the contacts on this face horizontally. So there is our block diagram. And again, you can see here is bed 6, 5, 4, and 3. So the older bed's the bottom, younger bed's the top. Okay, so let's look at the next block diagram. In this case, we again have a map view. Beds get younger from left to right. So 2, 3, 4, 5, 6. So this is the bottom of the stack. This is at the top. We have 2 strike and dip symbols. Again, now the beds are striking north and south, and they're dipping to the east at 45 degrees. So now what we can do is complete the front of this diagram. So try to make these dip at about 45 degrees. Again, in your lab, the way to do this would be use a protractor. You will have protractors in the lab. I'm just doing this by hand as a matter of time. So all these beds are dipping at 45 degrees to the east. And I'll just add another bed here again to kind of complete the front of that diagram. And now, because these beds are striking north and south, I can simply, again, draw these lines parallel or horizontal. So there is our second block diagram. So now let's look at some structures. So what we have now are some faults. So things to pay attention to. In both of these, what we're seeing is that we're given a cross section. So we have to reconstruct the map view and this other right angle cross section. So again, the beds are numbered from bottom to top. So the ones in the bottom are the oldest. And here is the trace of the fault line. And what you want to do is you want to compare the same beds on both sides of the fault line and see what their relative motion is. And so I've shaded in one of those layers so that it's a little easier to see. So what you can see, these two are the same beds, and here you can see the offset. And from that, you can tell that this side went down relative to this side. So now we can draw the direction of motion on this fault. So this side went down, and this side went up. Now, from our previous discussion, the block that sits on top is called the hanging wall. The block that's on the bottom is called the foot wall. When the hanging wall, a block on top, goes down relative to the other block, that's called a normal fault. So this is a normal fault. Now, we're not given what the orientation of that fault is, so I'm just going to assume for this diagram that this is going to strike, the fault is going to strike north and south. So that's the trace of the fault. Now, another important thing when you're looking at map views, one of the critical ways of telling what kind of a fault it is, or which side has gone up, or which side has gone down, is what the relative ages of the two units on either side of the fault are, okay? So here, this upper bed that's exposed at the surface is 6. The upper bed here that's exposed at the surface is 5. 5 is underneath 6, okay? So this bed is actually underneath this one. So for this one to be at the surface, this bed had to go up. So even without knowing the cross section, you know that this side had to go up relative to the other. So this side went up and this side went down. Now, just for completion, I can again just draw these lines across here to complete the other side of the block diagram. So there is our block diagram for that fault. So let's look at this second one. Again, the same thing. We have an exposure and a cross section, but we don't have any information for the map view. So we do the same thing. Beds get younger going up, so oldest at the bottom, youngest at the top. And again, we find a bed that we can trace, the same bed on both sides of the fault, and see what the relative motion is. So again, that's been shaded in so you can see it more easily. So in this case, here is this bed, and here you can tell that this bed has gone up relative to this one. So that means this block has gone up and this block has gone down. So here's our fault surface. Now we have the hanging wall block, the upper block of the fault moving up relative to the lower block. So this is the reverse of a normal fault, and so it's called a reverse fault. If this would be a really low angle, it could be called a thrust fault. Thrust fault is just a reverse fault with a very low angle dip. So let's see now what the surface map view of this looks like. Again, we'll put the fault line in. So we have the fault line. So again, we know that this block has gone up relative to this one. So here is bed 8 on the right side, and bed 10 would be exposed on this side. So that means 8 is below 10, so this block had to go up, again in agreement with our cross section. So we'll just draw the other beds in. We'll assume that these are all striking north and south. And again, we can put the numbers in. So this is bed 11, 10, 8, 7, 6, 5. So again, 8 is against 10. And this is our fault. Now, typically, where you mark faults on a geologic map is to mark them with these filled in triangles. That indicates that that is a fault, not a contact between units. And the points of the triangles point in the direction of the dip of the fault. So that tells you that the fault is dipping to the east, to the right. So again, just for completion, so there is our cross section. So let's try some folds now. So now we have a map view here. We see that all the beds are striking north and south. But if we look at the dip symbols, here are the dip symbols, these beds are dipping to the east. These beds are dipping to the west. So these are dipping in opposite directions. They're both dipping at about 30 degrees. So we can start by indicating the direction of dip by just putting little tick marks on that are pointing in the right direction. And what we see is we have beds that are dipping away from this central axis. So we know we're dealing with a fold. In fact, the beds are dipping away from the fold axis. This would be the fold axis of that fold. So that means we know we have an anticline. So we can go ahead and complete the front cross section. For this block. And we can add a couple more beds here just so we can see the structure maybe a little more clearly. So there is our anticline. Now, because the beds are dipping the same amount on both sides, this is called a symmetrical fold. It is also horizontal. The fold axis is horizontal. So this is a non-plunging symmetrical anticline. Again, if we were to number the beds, the oldest beds are in the center. So that's two things you look for. The oldest beds are in the center of the fold, and the beds are dipping away from the fold axis. Okay, that makes it an anticline. So you go ahead and just complete that diagram. So that block diagram is now complete. And so let's move down to this one. Again, we have a cross section, and we also have some strike and dip symbols on the map view. Notice that the strike and dip symbols indicate that the beds are dipping toward the center. And since these beds, these are the oldest beds at the bottom, youngest beds at the top, the youngest beds are in the center of the fold, so that makes this a syncline. And the strike and dip symbols say that the beds are striking north and south, so that makes it simple for us. So we just extend these beds. North and south. Like that. And we can put the symbol, the map symbol for a fold axis down the middle. So this is the fold axis. And again, it would be vertical So these two lines would mark out what's called the axial plane, and which is going to be vertical. Again, this is a symmetrical, non-plunging syncline. And again, completing that diagram. So, another diagram here. Now we have a map view. Notice now that we have not straight contacts between units, but these are curved. Okay, they actually have what's called a nose. So that tells us that we're dealing with a fold. That's what a fold looks like on a map view, right? So not only is it a fold, but it is a plunging fold. When you have a curved nose like that in the outcrop, in the map view, that tells you that it's a fold and that the fold is plunging. So is it an anticline or a syncline? Well, here are the beds, 1, 2, 3, 4. This is the oldest bed. The oldest bed is in the center of the fold. So that makes it an anticline. So this is a plunging anticline. So we can therefore go ahead and complete the front of this. We're not given strike and dips, so we can use some artistic license. And again, we can put another bed in here so we can see the shape of that a little bit better. So there's an anticline. Again, oldest beds in the center, youngest beds going up and out. So which way is it plunging? Well, it's a really good way to tell. In a map view, the nose of a fold of an anticline points in the direction that that fold is plunging. So that means that this bed is plunging to the south. So if again we put a symbol on here for the fold axis, like that, you put an arrow like that, which indicates that that fold is plunging to the south. And if we complete this side of the diagram, we just match up the lines and we can see, yes, indeed, these beds, or this fold is plunging to the south. And we can again add another line here. So that is our completed diagram, block diagram. Okay, the last block diagram we're going to look at is this one. It's a little more realistic. Folds very rarely happen by themselves. They happen in clusters because the land is being compressed or stretched or deformed, so you get a whole series of folds. So what information we have is, again, we can see that these folds have noses. They're curved on the map view. So these are plunging folds. And we can tell here what direction they're plunging. That is, they're plunging to the north, and which ones are old and which ones are young. So if I number these, so let's call this 2, 3, 4, 5, 6. So put it here so it's a little easier to see. For this fold, so we have 6, 5, 4, 3, 2. So this is the center of the fold. the oldest rocks are in the center of the fold, that makes this an anticline. In this case, we'd have 6, 5, 6, 5, 4. But this is the center of this fold, which is the youngest bed. So this is a syncline. And again, over here would be the same as this, 2, 3, 4, 5, 6. The oldest beds are in the center. That makes it an anticline. So we know we have an anticline, a syncline, and an anticline. So then we can go ahead and complete the front. Again, we have some guidance here. We can just connect these lines to start with. That's the beginning of our anticline here. And we know that this is a syncline. And again, this is an anticline on this side. So that's what we have from our surface information, and then if we can make another bed here so we can see the structure better. So again, here we have anticline, syncline, anticline, and these are all plunging now to the north. So these crumpled beds are all dipping, are all plunging down into the subsurface to the north. Okay, so what I want to do now is just briefly look at a geologic map. So we'll start here, look at this geologic map, and see what we can see, right? So this is a more realistic geologic map. This is actually a simplified geologic map from the Appalachian Mountains, just north of Harrisburg in the Valley and Ridge province. So what we see is we see these curved beds with these noses, which tell us that we're dealing with folds, and they're plunging folds. The strike and dip symbols here, so strike and dips, these strike and dip symbol says these beds are dipping to the right, to the east. This is dipping to the west. So these beds are dipping toward the center of this fold. Here is this fold. These beds are dipping away from the center of that fold. And over here, these beds again are dipping toward the center of this fold. So that's the first piece of information we have. And the second is the ages. Again, oldest bed, there's always a key on a map like this. It'll tell you the relative ages of the different units. The oldest bed's at the bottom, the youngest at the top. So by comparing with the key, this represents the youngest unit, the top. This bed here is also younger than the ones around it. So these are both synclines. This one in the center has the oldest bed in the center, so that makes it an anticline. So our definitions, syncline beds dip toward the axis. So here's the fold axis, toward the axis of the fold. And the youngest beds are in the center. In an anticline, the beds dip away from the center of the fold axis, and the oldest beds are in the center. Now, to make a cross-section of that, I won't take the time to do it here, but just to show you how that would work, you would hold a page here, just like you did for the topographic maps. But what you'll mark off here, what you'll mark off on the ticks, are the contacts between these different geologic units, and also take note of the dips of the beds. So you'd have that across your cross section, and then you would just transfer that to your cross section. In this case, the cross-section has the topographic profile as well. That's very common. So you do a topographic map, you do a topographic profile, and then you superimpose the geology on that. So then you would just take your tick marks here and then mark on the surface and extend them up, mark on the surface and what direction the beds are dipping. And then doing that, you can reconstruct what the subsurface is. So here's our syncline, our anticline, and our syncline. So I hope this is helpful, and take your time with block diagrams. It's definitely a learned skill.